Okay, I discovered some general rules for working backwards from the output number in red, this one cube, through the column, the adjacent columns, um, or rows or columns, whatever you want to call them, to the slabs adjacent to each other, perpendicular, back to the larger cube. See what this is? I call this a CSCC Matrix because it's named after the larger cube, which is the first C, the three adjacent perpendicular slabs, which is the S, the columns, the three adjacent perpendicular columns, which is the second C, and the last C is the smaller cube. From the larger cube to the smaller cube, and to the slabs and the columns in between. And you can put any array of numbers here, and they'll add up at each equation through the cube to equal this. What I did here, I didn't add from here. I figured out how to add backwards. How to start with one output number and go through to create the input numbers. One random output number, choosing any kind of output number. I chose 99, but you can divide that into three equations, or three parts of three numbers in an equation. 33 plus 33 plus 33, 33, 33, 33, 33, 33, 33. Working backwards in slabs, 11, 11, 11, 11, 11, 11, 11, 11, 11, 11, 11, 11, 11, 11, 11. And right here's the sort of tricky part, because you got to mix the nines with the ones in such a way to where they all equal 11. And if you look at this and you study this, if it's not too messy, you'll see that I did. It does work. I guess it might be easier to work with smaller numbers, because I put 27 here, and I separated it into three nines, and I separated it into the multiples of 9, which is 3, 3 plus 3 plus 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 3. And you separate the threes into their basic parts. There's 1, 1, 1, 1, 1, 1, 1, and all these are ones. And now this 100 is a little bit more difficult. I guess as they increase, it gets more difficult to satisfy every equation running through here. You don't need to satisfy the ones going across here to meet this. The ones going across here to meet this. The ones going across here. And I didn't finish this because it started getting messy. But another general rule, rather than just finding the multiples of the factors of a number, of each progressive sum, I guess, whatever it's called, you can simply reduce the number of equations if you have that option. But this matrix doesn't call for a 27 array number box, but it calls for like a 8 array number. And you reduce the equation by adding 50 and 50. So that leaves you with 4 equations here, and I'll show you, or it's 8 numbers, plus 50 and 50 is just 25, 25, 25, 25, and you see all these add up to 100. They add up to 50 right here, and go ahead and fill all these in. I'm doing it fast and it's going to be messy. Okay. So 25 going down and going across is 25 and 25, that's 50. 50 over here too. And then go ahead is 25 and 25 and 25 and 25 going up this way. Well, it's some sort of factors that go into 25. It's not multiples. It's not multiplication. It's factors. So I'm saying I'll guess. This is where the guesswork comes in. Guessing that 15, 10, and make it 15 down here and 10 up here, which is 25, 25, and also 25 and 25. So over here, from 25 you can go over here, put a 10 diagonal to this one, put a 15 diagonal to this 15. That gives you 25 and 25, and 25, 25. So over here, the last remaining thing would be to 15 over here, 10 down here. 10 and 15 is 25, 15 and 10 is 25, 10, 15 is 25, 15 and 10 is 25. And so that completes this initial input cube from the output cube. So it's a lot easier when you reduce the equations to satisfy 10, 10, 10, 15, 15 is 50, 15, 15, 10, 10 is 50, also 15, 10, 10, 15, 10, 15, 15, and 10 is 100. So the whole matrix is complete. So I think I found some general rules, but the last box, and certainly as you get with different random numbers, the more odd it is, the more difficult it is to work with. So, thanks a lot.